Um, Hello guys, this is Olu again, and I am here to finish up the paper 1 in one video. We'll be continuing now from question 9, but just before I start, I want to play some music at the background so that you would not feel bored, and it's going to help you relax your nerves as well. Yeah. Okay, I don't know what music that is, but I'm playing it anyway. Right, so as you can see on the screen, the question there is a fractional algebra one, and it's about dy dx. So here we go, question 9, and it says y equals 2x plus 3 over 4x squared plus 7. Find dy dx. Now, this should remind you of quotient rule. Quotient rule lets you deal with dy dx when you have a fraction. So pretend that the question you have is u over v. So if y equals u over v, quotient rule says that dy dx would be v du minus u dv over v squared. So can we tell what our u is and what our v is? Can we therefore tell what du is and dv? If we can, then let's do it. So u equals 2x plus 3, v equals 4x squared plus 7. If u is this and v is that, what's du going to be? What's the derivative with respect to x? Of 2x plus 3? That's just 2. And what's the derivative with respect to v? In this case, it's with respect to x again, sorry. That's 2 times 4, which is 8. X to the power of 2 minus 1, which is 1. And that's it. Because when it comes to differentiation, you always multiply by the power and take 1 away from the power. So I could have had x to the power of 0, because when you take 1 away from that, and x to the power of 1, because when you take 1 away from 2. But what's the point? That's just 2 anyway, and that's just 8x. Alrighty, so dropping all of this into the formula for quotient rule, dy dx can be easily sorted out. dy over dx is v du. That's my v and that's my du. So there we go, du and v. And then you have a subtraction sign there, and you're to do v du minus u dv. So u dv. So that's going to be 8x into bracket u, which is 2x plus 3. And we divide all of this now by v squared, which is 4x squared plus 7 all squared. Now we can finish this up by expanding the top brackets. So we have 2 times 4x squared. And I'm sure most of you are familiar with how to expand, so I shouldn't be talking too much about that. I'll just do it. Right, I need to simplify the numerator, and that gives me minus 8x squared minus 24x plus 14 over 4x squared plus 7 all squared. Now that is the that's the dy dx sorted now. So you get 2 marks, or whatever the number of marks is for that. And then the next part of the question, so if we scroll down a bit, it says hence show that y is increasing when 4x squared plus 12x minus 7 is less than 0. Now that's a tricky question, but from the fact that they've said hence or otherwise, that should let you know that it shouldn't be much of a hassle going forward from the one we have just solved. Now I'm going to tell you something about increasing functions before we solve this problem. So perhaps this would help you a lot. If I draw something like that, and it's a graph of f of x, what do you think would be the gradient at this point? 0, right? So dy dx is 0 at the peak. What do you think about the gradient on this side? It's positive. So dy dx on this side is positive, or I can just say greater than 0. What do you think about the gradient at this position or in this area? It's negative. So I could say dy over dx is always going to be less than 0 on that side. Now this is called an increasing function. This is called a stationary point. My handwriting is terrible, and that's because I don't care. And at this point it's called a decreasing function. So think about this. When gradient is positive, it's an increasing function. It means it's going up. When gradient is 0, it means it's stationary, it's not going anywhere. And when gradient is negative, it means it's a decreasing function. So for God's sake, how easy would this question be if you know that? It says, hence show that y is increasing when blah 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 is less than 0. Well, all we need to say is that if this is my dy dx, you know, if I've given you dy dx to be this one, then for it to be an increasing function, it means this must be greater than 0. So that's all we need to introduce in the answer. So we'll just say question 9a, Roman figure 2, dy dx greater than 0, increasing function. And we've already given dy dx to be minus 8x squared minus 24x plus 14 over 4x squared plus 7 all squared. Now that has to be greater than 0 for it to be an increasing function, right? So can we rewrite this to look like exactly what they want us to have? Yes, we can. This at the bottom here is a squared number because you've got a square there. And whenever you have a square there, it means it's always positive. Fine. If I have to divide this by a positive number and my answer needs to be positive, what do you think about this numerator guy? Can it be negative? Is negative over positive ever going to be positive? No. So the numerator must always be positive. So we can only have positive over positive, giving us positive. So if we are already convinced that our denominator can only be positive because it's a squared number, then for that to give you a fraction that is positive, your numerator must be positive. So all I would say is that minus 8x squared minus 24x plus 14 must be positive. And that's it. Now, the question has something different from what we have. So they seem to have factorized something. And it's not a problem. We would do it as well. I'm just trying to be slow about how I do it so that you don't get confused. Can I factor out negative 4 on the left hand side? Is that okay? Or no, we can't factor out negative 4 because of this 14. Can we factor out negative 2? So if I take out negative 2, I have my bracket there. And all I have left in this bracket is 4x squared plus 12x plus, minus 7. Okay. Now this is similar to what we had talked about with the fraction positive and negative thing. Now what you have outside this bracket is a negative number, negative 2. And what you have in this bracket here is a function. We don't know whether it's positive or negative yet. But when we multiply the two of them, we want the answer to be positive, greater than 0. So negative times what would give you positive? Can negative times positive give you positive? No. So what must be in this must also be negative, and that's when they multiply to give positive. So if this is already seen to be negative and the answer must be positive, then it means what we have in this bracket, the function here, must now be negative. So we can therefore say that 4x squared plus 12x minus 7 must be negative. And that's the question we were told to prove. That's what we're told to prove. So if it's an increasing function, dy dx must be greater than 0, and the whole of the fraction now can be simplified to that Okay. Just bear in mind that if you're ever confused about anything, well, you've got many options. You could contact me by Skype and we could talk about it, or you could probably just Google some things, and before you know it, it will be very clear to you. So let's scroll again to the next part of the question. It says, find the values of x for which y is increasing. Now they want us to solve that quadratic inequality. So the good thing is that even if you are not able to prove the answer for this, well, just take this and solve for the next question, and you might just get your answer right. Many people may not be familiar with how to solve quadratic inequalities, and not because they don't know how to do it, but because there are so many methods, and some methods are easier than some others, but it all depends on who is solving it really. So let me try to show you an easy way of solving quadratic inequalities. I have videos on it on my channel, but don't worry, I'm not going to send you to go start reading or checking my videos. Okay. So we have 4x squared. Where is it now? So quickly back to the question. We have 4x squared plus 12x minus 7 less than 0. We are told to solve for the values of x. No problem, we will do it. First, you want to factorize this. So you want to put this in brackets, and then we can take it from there. Right, this is normal quadratic, so how would you factorize that? Again, many people have different ways of doing it. I don't know whether to use one method or the other. I'm not sure what you would like. Let me use the method that I said I would always use. I'm going to have MAM written on top of these guys. So if I have MAM written on top, I need two numbers that multiply to give whatever the m's multiply to give, and those two numbers should add up to give whatever the a gives. So we want two numbers that multiply to give that and add to give that. So I'm looking for two numbers that multiply to give whatever this multiply to give, which is minus 28, and they should add up to give what this is, which is plus 12. What two numbers do you think would be using? 14 and negative 2? Yes, exactly, those are the two numbers. So I'm going to put 14 and negative 2 in the bracket. I have 4x squared. What do I do? Should I have 2x here and 2x there? Yes. So 2x and 2x. But that's not right. Sorry. No, it should be 4x on both sides. For now, we don't know which is going to disappear, but it's going to be 4x on both sides. I'm sorry that I've done this wrong. I don't know why, because I've repeated this severally in the previous videos. Now that we have 4x, because we were meant to put 4x in one of the brackets, but we chose to put in the two brackets, hoping that we would solve it later when we factorize. Now the next thing is, which of these brackets can we factorize? And remember, the rule here is that whatever goes out of the bracket would never come back. Can this be factorized? Yes, it can. Can that be factorized? Yes, it can. Good. We would factorize whatever can be factorized, and whatever goes out would never come back. Okay, so what do you think would go out of this bracket? 2. So when 2 goes out, we are left with 2x minus 1. The 2 that went out is not coming back, forget it. What do you think would go out in this bracket? 2 again? Yeah. So when 2 goes out, we're left with 2x plus 7. 2x plus 7. And the 2 that has just gone out again would never come back. And that's your factorization done. So we have now factorized the quadratic inequality. It's left for us to solve. Now, if you have 2x plus 7 into bracket 2x minus 1 less than 0, each of these represent 2 points, right? I mean, they both represent 2 points. This represents a solution that says x is equal to a half, and this represents a solution that says x is equal to negative 7 over 2. That's negative 3.5. But we're not saying that that's the solution to the problem. That's just what these brackets represents, or this factors represent. So we would now draw our number line and indicate those factors. So these are the factors we have indicated on the number line. That's just a number line, and we've indicated those factors. So my question to you would be, which region would be our solution? Would I shade those circles? Would I shade them? No, I wouldn't shade the inside of the circles because we don't have less than or equal to. We just have less than. Right, this is something that you could solve again in several ways, but the way I want you to learn to solve it is this. What this inequality is telling us is that the product of this bracket and that bracket should always be negative, less than 0. So negative times negative would never be negative. It would be positive. So that would not work, right? We are going to test numbers in any of the regions, in any of these regions. And whichever region passes the test would be the solution. And any region that fails the test would not be the solution. So I could test a number in this region. What number would you choose to be in this region? Anything less than minus 3.5. Can you say minus 100? Yeah. I could test that number and see whether it would give me negative when x is minus 100. I could test a number in this region, a number like 100. You know, anything greater than 0.5 is in this region, so 100. When x is 100, would that agree with the inequality sign here? Would it be negative? Would the answer be negative? I could test a number in the middle here. What number do you think is between minus 3.5 and 0.5? Well, I know there will be a 0 somewhere there. So we could test for 0 to see when x is 0. Does this inequality product give us anything negative? Now, if this region should pass the test, then these regions would fail the test. These two regions would fail the test. If the region in the middle here should fail the test, then the two regions on the other side would pass the test. So there is no need trying to test for this region and that region. Just test for one of these regions, and if it passes, it tells you that the other two have failed, and if it fails, it tells you that the other two have passed. If you choose to test in this region, if this region should pass the test, then it means that that region would also pass the test because they are twins, okay? And if these two regions have to pass, this middle region would have to fail the test. All right, enough of the talking, let's do it. I'm going to test for the region 0. So let's see, when x is 0, do we have a negative? 2 times 0 is 0. 0 plus 7 is 7. That's a positive, right? 2 times 0 is 0. 0 minus 1 is negative 1. So that's a negative. A positive multiplied by a negative answer here would always be negative. So that means this region would pass the test. So if 0 passes, that means everything in this region would pass the test. These regions here would fail the test, because if this region has passed, the other regions have to fail. If this had failed, let's say this had given us a positive answer when we know that the inequality says it must be 0, less than 0 rather. If this should fail, then automatically these two would pass. So this is my solution. My solution is therefore minus 3.5 less than x less than 0.5. Alrighty, that's the question 9 solved. Now 9b solved. So the next is question 10, and I think I should do that in this same video. I don't want to break videos so that you don't have to start, getting confused. Nice music, isn't it? The function f is defined by f of x equals 4 plus 3 to the negative x, where x is a real number. Using set notation, state the range of f. There are two things. We have the range and we have the domain. The domain is the family of x values. The range is the family of y values, or let's say f of x values. So the range of f would be, what are those values of f that we can ever get from this function? The domain will be, what are the values of x that we can actually use into, as input in this function. So for this time, in this question, we're only looking for the range. So we've been given f of x to be equal to 4 plus 3 to the negative x, and x is any real number. What are those possible or impossible values? There is nothing impossible about 4. 4 is 4, whether you like it or not. So 4 is okay. But are there some impossibilities with this guy here? Well, maybe that will not be too obvious yet until I rewrite it. So let's rewrite this as 4 plus 1 over 3 to the x. Do you agree that 1 over 3 to the x is the same thing as 3 to the negative x? Okay, so now it's beginning to make some sense. Can the number at the bottom ever be negative? Can it ever be negative? No? No, it can never be negative. 1 over 3 to the x can never be negative because 3 to the x can never be negative. X is just a power. If you raise 3 to the power 100, it's positive. If you raise 3 to the power 0, it's positive. If you raise 3 to the power negative 1 million, it's still 0.0000, but it's still positive. So this number here, the lowest it can go is 0. It can never be negative, and it will be 0 when x is at infinity. So the minimum that f of x can ever be is 4 plus 0, which is 4. But the maximum that f of x can be is 4 plus the maximum that this would ever give, which is infinity, and that gives infinity. The reason that this has a maximum number of infinity is because 1 over 3 to the x, which is 3 to the negative x, would be infinity if x is negative infinity. So let's say when x is a very large number, like negative 1 million, what do you think 3 to the negative x would be? That would be 3 to the negative 1 million, and that's 3 to the 1 million, which is a very big number. So the maximum the solution here would give you is infinity, and the minimum it would give you is 4. So how do we write this in set notation? Something has a minimum number of 4 and a maximum of infinity. You would usually just put 4 comma infinity. But then the problem is, do you want to put a round bracket on both sides, or would you put a square bracket on the 4 and the round bracket, or what? So here's something I need you to know today. You know, when we talk about less than or equal to, when we talk about less than or equal to, that's a square bracket. When we talk about greater than or equal to, it's also a square bracket. But when we talk about strictly less than, that's a round bracket. When we talk about strictly greater than, that's a round bracket, parenthesis. So if there is no equality option, you don't use a square bracket, you use a round bracket. Now the question is, can 4 ever be obtained, or can infinity ever be obtained? Like I said, 4 would only be obtained when you get to the lowest value of 1 over 3 to the x, which would only happen when x is at infinity. And the truth is, x would never ever be at infinity, because infinity is just an imaginary number, okay? So if x would never go to infinity, then 1 over 3x would never ever get to 0, and so 4 plus whatever would never ever become 4. The same thing here, you would never really have anything called infinity, so we don't usually include infinity in our intervals. So what this means is that it's going to be round brackets instead. It's not going to be square brackets, it's just going to be round bracket for both of them, because they would never really happen. Okay. Having said that, find the inverse function of f. The inverse function of f. If we've been given f, why can't we just find the inverse? Of course, to find the inverse function, you just need to rearrange the formula to make x the subject. So f of x has been given as 4 plus 3 to the negative x. So when it comes to finding the inverse, what you're trying to do is you're trying to make x the subject of the formula. So let's begin to rearrange. I'm going to take this 4 to the other side. So f of x minus 4 is 3 to the negative x. Alright, we are getting there. We just need to make x the subject. Can I invert both of them? So let's do 1 over, because I know this is 1 over 3 to the x, right? This is what it is right now. Oh, sorry. This is what it is right now. So why can't I just flip both sides? So this becomes 3 to the x and that becomes 1 over f of x minus 4. I do apologize for my terrible handwriting. I guess it was due to the kind of nursery school I went to. Whatever it was. Now we are almost there. We just need to make x the subject. And what do you think is the thing to do when you have x as a power? You take ln of both sides, or do you take log of both sides or something? Yes. So if you look at your formula sheet, the laws of indices I think are there. To be honest, I don't know if it's there, because I don't think we need it. We don't need those laws, okay? We know it, don't we? That's the power, so it becomes the subject. That's the base, so it stays as the base, right? And that is the number, so it still stays as the number. And that is how to rearrange indices into logarithms. The power becomes the big guy. The base which is under the power is still the base under the logarithm, but the number we were talking about is still the number we are looking at. So the power becomes the big guy, the base stays as the base, and the number stays as the number. Okay, and there we have x as a subject. We need to rewrite this as inverse function, so we change x to f inverse. That's just the way we like to write it. And wherever you see f of x, we now write it as x to base 3, and that's it. Okay, now some people would rather divide it by log 3 rather than put base 3, but it's all the same. Okay, good. Now the next question wants us to sorry, I'm so sorry. I think I jumped the step. I went all the way to 10b Roman figure 2 when I should have solved the 10b Roman figure 1. 10b Roman figure 1 says, using set notation, tell us the domain of the f inverse. And of course, that's just a tricky question. I bet it's for 1 mark. Yes, it's just for 1 mark. And the reason is, when you have your function, a function, like I told you, takes your domain to your range. So a function would usually take x and give you y. That's why it's called a function. It takes x and gives you y. It takes x from the domain and gives you a y that belongs to the range. So the inverse function is just going to do the opposite. It's going to take from y, which was in your range, and it's going to give you x, which would be within that domain of the previous one. But the thing is, we don't call this range, even though it's on this side. We still do not want to call it range. I mean, because even though it's the same one, we call it the domain of the inverse. So I'm not going to call it range, I'm going to call it the domain of the inverse function. And I'm not going to call this one domain, I'm going to call it the range. That's the new range of the inverse function. But what you would notice is that the range of the inverse function is the same thing as the domain of the actual function. The domain of the inverse function is the same as the range of the actual function. So if they've asked you in 10a to find the range of the actual function, and in 10b they're asking you to tell them the domain of the inverse function, it's just for you to look at it and say, this is it. So of course the range, the domain of the inverse function is the same thing as what we said in the answer for the range of the domain, which was this, comma that. Okay, dokie, and we have solved the second part of the question, which was asking for the expression of f inverse. Now let's go to 10C. 10C seems to be taking the battle home. It says g of x equals 5 minus root x. Given that x is all real numbers such that x has to be positive, find an expression for gf of x. So we already know that f of x is 4 plus 3 to the negative x, and g of x now has been set to be 5 minus root x. We're told to find the expression for gf(x). Alright, maybe you already know how to deal with questions like this, but I need to make something really clear to you. When I was teaching in a classroom some time ago, I asked the students, does anyone here like fish? And they were like, we don't like fish. And how does this have to do with fish? Well, here's how it has to do with fish. Do you know that fish swallow fish? Like, I don't know if that even sounds grammatically correct. Fishes swallow colleagues. They swallow themselves. So a fish can swallow another fish, okay? Depends on the size. Now, this is a function. G is a function, f is also a function. But g can swallow f, and when g swallows f, we call it gf. If f swallows g, we call it fg. It's not a multiplication, it's a swallow, okay? Can you say after me, swallow? Now, g is going to swallow f to give you 5 minus square root of whatever it has swallowed. Usually g is meant to swallow an x and do the square root of that x, but now it's going to swallow the f, and so it's going to be square root of the f. But f is not on its own. F had already swallowed x. So it's not just an f, it's an f that has swallowed x. So instead of writing 5 minus root fx, let's strip f out of its shell and see what it actually was. F was actually 4 plus 3 to the negative x. So it's not just an f, it's 4 plus 3 to the negative x. And there you have it, the expression for g of f. We cannot simplify it any further, so that's where it stops. And that's your gf of x. So that's g swallowing f. If you're told to find fg of x, then you can still do it. The next part of the question says, solve the equation gf of x equals 2, given your answer in an exact form. Okay. 1 second. Right, I'm just wondering, what do they want? They want us to solve for x, given our answer in the exact form. Now, whenever you see the word exact, leave your answer in the exact form. Find the exact value of this. All they are telling you is that do not change it to a decimal. Leave it as a fraction. Leave it as an irrational number if it's pi, if it's epsilon e. Do not change it to a decimal. Do not ever try to approximate things. Okay, so that's to, you can leave it in short form as well. Right, so to solve for g of x equals 2, we already know the expression for g of x. We just need to equate that to 2. So if g of f of x equals 2, that means 5 minus square root of all that jargons you saw earlier would be equal to 2. Now this is all about rearranging. So if I want to have this separated from all those other numbers, I don't know how to break this down for you guys. Well, you know that this negative means that this guy, when it goes to the other side, becomes positive, right? And this one is a positive 2, so when it comes to the left hand side, it becomes negative. So that's just 5. The 2 comes here to become negative 2. The root sign goes to the other side to become positive of itself. So that's that. The only way to get rid of the root sign is to square both sides. But just before you square both sides, remember that this is 5 minus 2, which is actually 3. So when you square 3, you get 9. And when you square this side, it only knocks off the root sign. It doesn't help you square any further. Right, what do you do to get rid of the 4? Subtract 4 from both sides, so that leaves you with 9 minus 4, which is 5, and 3 to the minus x. Almost there, would you say? 5 equals 3 to the minus x. Hang on, moving to another page. So 5 equals 3 to the minus x. And of course, this is again one of those things you would be used to by now, indices to logarithms. Again, I would prefer to write this as 1 over 3 to the x. So can I swap places? Can 3 to the x go there, and can 5 go down there? Yes, it can. But why all that? Why should we even stress ourselves to do that when it wouldn't help us? It wouldn't help us anyway. I can go straight from that indices form to logarithm. Again, let's do it. So forget what I just did. We had 5 equals 3 to the minus x. Remember what I said. The power becomes the big guy. The base still stays as the base of the log, and the number just stays where numbers should be. So the power is that, so it's the big guy now. We've got log. This is the base under that power, so it's still the base there. And the number just stays where the numbers should be. And that's it. You can use a calculator, you can do whatever you want to do. Some people would have their answer as, okay, sorry, and then when the minus sign goes there, it becomes minus log 5 or to base 3. Of course, you could have it as minus log 5 over log 3. You could have it as minus ln 5 over ln 3. Mathematically, they are all correct. Okay, moving on, let's see what other question we have. Is it question 11 now? Alright, I promised I was going to do all of this in one video, so you don't have to be checking for new videos. But I think that I should stop this video now so it doesn't get too long, and when you're ready you can carry on with this. So in the next video we're going to continue with question 11. If you have questions, remember what I said. Okay, just for those of you that may not have been here when I said that, you can Skype me if you have questions. Just drop your message on Skype and I'll reply you on Skype. I'll just reply your text. My Skype is olusola.ayoola. Oh, it's just too long. Now I can't even squeeze it in anymore. Okay, we'll manage. 2014. Okay, it's been a long time I had this Skype running, so yeah. olusola.ayola 2014. Hopefully I'll leave this in the comment section below. I know I might forget to do that, so bear with me. Okay, I'll catch you in the next video. If you like, run away. I'm still gonna catch you in the next video anyway. Bye.